So here we have sines and cosines. So let's figure out what to do here. Usually we want to try and get 0 on one side. What would not be productive here would be to do something like divide both sides by the sign. When we do a division with a variable, we introduce the problem of dividing by 0. So we want to try and avoid that. So that would not be a good idea. So I would subtract the 8 sine over. So 18 sine of t cosine of t minus 8 sine of t equals 0. So I'm kind of thinking about the last few problems we worked on where we got 0 on one side, we were able to factor the other side. Can I factor this? The answer is yeah. On each side of that subtraction, I have a sign. Also, these two numbers are even. So I could factor out a 2, and I can factor out a sine of t. And then I want to see what's left behind. So 2 goes into 18. That's going to leave me a 9. I took the sine, so that leaves a cosine. Minus 2 goes into 8. There should be a 4 left behind, and I took the sine, so that's it. So now I have a product equals 0, and so I can break it into two different parts, right? So we split here. So now I get twice the sine of t equals 0, or 9 cosine of t minus 4 equals 0. Dividing by 2 on the first one gives me the sine of t equals 0. And thinking about the unit circle, when is sine, the y value on the unit circle, when is the y value equal to 0? So thinking about the unit circle, y equals 0 here and here. So that would be at t equals 0 or t equals pi. So I get two solutions there, and I'm looking for solutions from 0 to 2 pi, not including 2 pi, right? So although I could go around 2 pi as an answer, it's just outside the interval I want. So it will solve this equation, but it's not in the domain I've been asked about. All right, let's try this one. Add the 4 to the other side. Divide by 9. All right, thinking about the unit circle here. Cosine is an x value on the unit circle. So 9/4 is just under a half. So that would be about here. So x equals, 4/9, not 9/4, equals, that gives me this point up here, or this point down there. And the arc cosine is familiar with the whole upper part of the circle. So it's going to give me that one right there. So this one right here would be t equals arc cosine of 4/9. And the other circle related to the cosine is thinking about that as a reference angle there, that cosine of 4/9. This right here, that reference angle is also 4/9. So if I spin around 2 pi and then back off back here, that's going to be that solution. So the other solution is t equals 2 pi minus the first solution. So like with the sine, the other solution that the arc sine doesn't know about is always pi minus. With the cosine is always 2 pi minus because of the symmetry on the circle. So one solution, again, t is equal to whatever the arc cosine of 4/9 is, and the other one is going to be pi minus that. And we'll figure out those on a calculator, see how the answer needs to be put into the computer. So it looks like there are 1, 2, 3, 4 solutions from 0 to 2 pi. We're going to graph to confirm. All right, so let's graph the function first. So our function, we had two different functions. You should always graph the way it was originally given. So the original version was 18 sine, we got to use x, cosine oops, cosine of x. That was the left side. Ooh, that's interesting. And then the right side was 8 sine of x. Make sure I got that right. So I'm using x's instead of t's to graph it. Yep. So graph the left side, graph the right side, and we just want to figure out where they're equal. And let us rescale this a little bit. Let's go up higher and lower. So how about maybe -20 to 20? That's far enough. And then I really only care about the positive solutions. I'm just going to move over a little. And let's change the x. That's getting, it's pretty though. We really only need to go out to like 2 pi is 6.28. So let's go out to 7-ish. All right, so I determined that there should be, these two waves should meet at 0, which they do right here, and they should meet again at pi. And then the other solutions I found between 0 and 2 pi, one of them should be right there. So that should be that arc cosine of 4/9. Let's check that. Let's call that solution A. Arc cosine or cosine inverse of 4/9. So that was this one right here, 1.11. And then the 2 pi minus that should be this intersection down here. And notice it's less than 2 pi, which is over there. So if I say B, my other solution should be 2 pi minus my solution A, 5.17-ish. That should be this one down here. There it is. Okay, so we have our 4 solutions. And again, I mentioned before, every problem is different. Sometimes there's 2, sometimes there's 1, sometimes there's 4. It could be there's no solutions. That happens sometimes too. Sometimes things just ain't equal. Give your answers accurate to 2 decimal places, comma separated list. And then sometimes clicking the more will tell you more. Enter a calculation. All right. So 0 was one solution, comma. Pi was another solution, comma. How many places accurate to 2 decimal places? 1.11 was a solution. And 5.17 was another solution. And sometimes if it says enter a mathematical expression, we can even type things like arc sine, and sometimes it'll recognize that in the computer. I'm kind of curious if this one will. Submit. Yay, I got them right. So let's suppose instead of the 1.11, I tried to type it as the arc. What was that one? Arc cosine of 4/9. Will it understand that? Oops. Not if I don't screw up the parentheses. Okay, I like that one too. So again, when you do click on one of these, let's get a similar version. Make sure you read the fine print to see what kind of answers it'll accept. Sometimes down here, it'll say, don't enter trig functions. Okay, so if it says don't enter trig functions, don't type something like the arc cosine. But often the system is programmed to accept such answers. All right, let's try another.